All right, I know that you're probably sick of these, but we're still not done. So we are on acid-base equilibria, and this is part 8. I know, awful. I'm Ms. Bedrosian, of course. In this section, we are going to look at something called polyprotic acids. These are acids, obviously, with more than one hydrogen that can come apart. So we're specifically going to look at that. I have an example to show you, carbonic acid. This has 2 hydrogens. The first one comes apart as follows, and you can see the Ka1 for this one and what it becomes. So this is just the first hydrogen coming off. So you have H plus HCO3 negative. Then the second hydrogen comes off, and please note the Ka2 is vastly different. It is much more difficult for the second hydrogen to come off and get these results. So this comparison is what you have to look at when you are looking at polyprotic acids. Now I'm going to walk you through an example. And this example, I'm going to condense the steps from the previous ones. So now that you have the idea, I think you can condense them. So you're given 5.0. This has 3 hydrogens. This is 5.0 molar solution. Please look at K1, K2, and K3, and you can see quite the difference between them. Take a look at those. In this example, you are going to have to solve several things. pH, concentration of H3PO4, H2PO4 negative 1, HPO4 negative 2, and PO4 negative 3. That's a lot of things you have to solve. So let's take a look at this one. We'll walk through this one together and see how you're going to use it. As always, please look at the dominant species. According to Ka, the dominant species are H3PO4 and, of course, water. This is what's actually mostly in your container. That's what that means. So Ka1 is dominant. And here's the equation that you need to set up. Always write the expression without any numbers. H plus times H2PO4 negative over H3PO4, that's Ka1. Expressing that mathematically, x squared over 5.0. So solving for x, that will solve for your 2 concentrations. That's what you will get when you solve for x, concentrations of these 2 species. And that came out to be 0.19 molarity. Great. Now you should be able to solve for what? Well, now you can solve for pH. Remember the negative log of the concentration of hydrogen ions. It came out to 0.72 is the pH. Now, but I asked you to find the concentrations of other things as well. Since we solved for x, and you should have made a table, then at equilibrium, H3PO4 should be 5.0 minus x, which came out to 4.8 molarity. So at equilibrium, now we have the concentration of this. So we've already answered a couple of questions here. Now let's look at the next part, Ka2, and write the expression again for this so you know what the species are. However, think about this. This is not x squared anymore because that hydrogen ion concentration comes from the previous Ka1. It's dominant. So that's 0.19, and we figured out H2PO4 negative, also 0.19. So now you plug that in and you find HPO4 2 negative, and there it is. So this is Ka2, and now you found another thing on the list that you need to know. Now the next one, you're going to do Ka3. Again, write out the expression, and there are two things here you know. Hydrogen ion is going to be that 0.19, and now we just solve for HPO4 2 negative, plug that in on the bottom. And now you're solving for the concentration of PO4 negative 3. It's kind of like a little puzzle. And there it is. So now you have solved for everything you need to solve for this. Now we've always gotten rid of that minus x, but do you really adore quadratic equations? Well, next one's for you. 3 points extra credit if you show all the work, and I mean all the work, everything, for the following and hand it in tomorrow. Shh, I don't expect you to tell anybody. This is a secret. I don't want to see everybody if I see every single person handing it in tomorrow, I know you told everybody. No telling anyone else. Here it is. You like quadratics? Here it is. Bonus. Sulfuric acid is a strong acid. For the first hydrogen only. You are given a 1.0 molar solution. Ka2 is 1.2 times 10 to the negative 2. What do you have to find? You need to solve for pH. This is a secret. When you've watched this, turn it in the next day. This is end of part 8. All right, I know that you're probably